Hello! Today we are going to be talking about patterns and how they show up in algebra and how algebra is also a way to describe patterns. Turns out algebra is everywhere. So first, we're going to do just a little bit of review because it might have been a while since you have been working on patterns. Now, this is something that we covered as fourth graders, but it's always good to have a little bit of review. So whenever I am working with a numerical pattern, and I have a series of numbers, I know that I can figure out the pattern by looking at the changes. I'm always going to go from one term to the next and say, how did I get there? If the next term is bigger, I know there's only two options. I either had to add something or multiply something. If the number is smaller, there's only two options. I know I had to subtract something or divide something. Now, on the off chance that it's just the same number over and over and over again, you could be adding 0, subtracting 0, multiplying by 1, or dividing by 1. But we rarely see that kind of a pattern when we're doing these assignments. So the first question that we're going to be starting with then, we have a lovely pattern here. And we want to find out the next three terms in the pattern, and we want to describe the rule of the pattern. So the first thing that I'm going to do is I'm just going to get started here and say, all right, from this term to the next, is it bigger or is it smaller? Well, 1 to 2, that's definitely bigger. I don't know which of these it is yet, though. So to get from 1 to 2, I could add 1, or I could multiply by 2. Now I'm going to go to the next set of terms. Is it bigger or is it smaller? Oh, well, it's bigger again, adding or subtracting, or adding or multiplying rather. To get from 2 to 4, I'm either going to add 2 or multiply, by 2. Now I notice these are not the same, but I notice these are. And I'm going to bet I have a multiplying by 2 pattern. But I'm not done yet. I'm going to test it. Now to get from 4 to 8, is it bigger or smaller? Bigger. I know my only options are adding or multiplying. 4 plus 4, or 4 times 2 is 8. I have seen times 2 for every single one of those. I bet that's the rule. Now I'm going to test it and say, okay, if I'm doing times 2, 8 times 2, it is 16. So my rule is going to be times 2. I could also write it out in word form and say multiply by 2. That's fine too. Now I know I've got 3 more terms, x, y, and z here. So my next term, I'm going to have to multiply by 2. Now I can always do a little bit of extra scratch paper work. 16 times 2, 2 times 6 is going to be 12. Regroup, 2, 3. Okay, this one, it's going to be 32. After that, I need to double this one. Oh, okay, well, 32 times 2, that's 4, 64. And then 64 times 2, yes, we're doing the powers of 2 here if you recognized them, is 128. So I know the rule is multiplying by 2, and I know that the next 3 terms, when I erase all this other work and I simplify it all back down to show you, I simply have, we'll even do it this way and show you just on the lines, 32, 64, and 128. And there we have it. A beautiful pattern. We know what the rule is. All right, we're going to do one more together. So here we have our terms, and we want to find the next 3. And we want to find the rule. So again, I'm just going to say, how do I get from here to there? So first off, 400 to 300. Is it bigger or smaller? Oh, It gets smaller. That means my only options are subtracting or dividing. So I'm going to try each one. 400 to 300, oh, that's subtract 100. Or divided would actually be like there's not an easy one, right? There is an answer, but minus 100 was really easy, right? So when I look at this and I say, oh, the very next one is minus 100 right away, if you can see the pattern, you don't even have to try the other operation if you go, oh, I know what this is. So what's the next one? Well, 200 minus 100. Well, that should be pretty simple, right? It's just 100. Next term, 100 minus 100. Oh, what's that going to be? 0. And then to get to the next one, it's 0 minus 100. Oh, minus 100 equals negative 100. So there's a little extra fun one for you. The rule here is going to be subtract 100. I could write this out in words, or I can use the symbol subtract 100. And there we again have figured out our 3 next following terms and our rule. So while you're working on patterns, it is important to remember that sometimes it's not always the same rule over and over and over again. So this time I'm going to start with the rule and have you build the pattern. The rule for this one is times 2 plus 2. You might have a pattern with more than one operation. So if I start at 1, my next term is going to be times 2. 1 times 2 is 2. My next term is going to be plus 2. 2 plus 2 is 4. Then my next term is going to be times 2. 4 times 2 is 8. Then I have plus 2. 8 plus 2 is 10. Then I have back to times 20. Then I have adding again, 22. And I can continue this pattern to infinity and beyond. Again, it's important to test going between each one of these numbers because you could end up with a rule that has more than one operation. We're going to do one more where I give you the rule. In this case, the rule is minus 2 times 3. So in this one, we are going to start at the number 10. It does make a difference. You need to know where your pattern starts. If you don't know where it starts, then you can't really do much past that. No, it's 10 minus 2 equals 8 times 3. 8 times 3, 24. Then I go back to my minus 2 times 3 minus 2, and so on. The pattern will continue forever and ever to infinity. So if you are trying to find the pattern, don't forget it could have more than one operation. And if you are trying to find the next term in the pattern, make sure that you always check your work on paper. Don't just try to guess what it is. You'll take a lot longer and be much more frustrated. So go ahead and work it out, always starting with the basic questions of, if I go from this term to the next, is it getting bigger? Is it getting smaller? You only have 2 operations to choose from in either of those cases. So good luck and have a wonderful time working on math.